Good morning. I guess our bench already here. Morning, sir.
Morning.
Okay, we wait for Bu Cici maybe before we start the lecture.
Finally, I meet you.
Yeah.
And soon on Monday, I will see you.
Yeah. We'll meet.
Yeah.
Hello, good morning, all of you.
Morning, Bu Cici.
Okay, thank you, Bu Mila, for arrange of this guest lecture. Morning, Bensko.
Morning, ma'am.
Okay.
So we can start the lecture now, Bu Cici.
Okay, wait a moment. I will try to find my headset first, Bu Mila.
Oh yeah, okay. Yang bisa nyalakan kameranya boleh dinyalakan adik-adik, biar kelihatan mukanya ya.
Okay, let's start, Bu Mila.
Okay. Well, we will start the lecture now. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Thank you very much for joining the guest lecture held by Department of Mathematics, Faculty of Science and Technology, Universitas Airlangga. And today we have Sir Benchko Fabros as the speaker of our lecture today. Thank you very much for Sir Bench for coming. Even it's virtual, but it's okay, yeah. Hope we will get new knowledge from Sir Bench, because usually we have class with Indonesian lecture, but now we have someone from Philippines, so I guess many students excited with this lecture. So before we start the lecture, maybe there is some opening speech or welcoming speech for Bu Cici as the Secretary of Mathematics Department. So for Bu Cici, the time is yours.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Your Excellency, all of the lecture, Department of Mathematics, and of the students, Department of Mathematics, Faculty of Science and Technology, respected college, it is my pleasure today, on behalf of Mathematics Department, to welcome all of you to this guest lecture, our new partner, Bensko Fabros, from Tarlac Agriculture University, Philippines. Welcome to Benz. Hopefully you enjoy for this guest lecture. Hopefully you enjoy how to deliver this lecture, and then the student able to get a lot of knowledge from this guest lecture. Okay, now I can say that it's very grateful for us to that you can spend your time to give a lecture here. The topic of our guest lecture today is differential calculus, and with increasing complexities and our work today, the calculus is the foundation of the basic all of the mathematics major, and then hopefully it gives a wider knowledge about the mathematics for the students. This is last but not least, there has been a collective effort being put to run this guest lecture in one form or another. On behalf of our department, let me take this opportunity to express my high appreciation to all of those that has contributed. Finally, again, welcome to Bensko Fabros from Philippines, and we hope all of the students enjoy this guest lecture. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Bu Cici. And now we will take the documentation first. So for all the participants, please open your camera and give your best pose, because we will take your picture. Oke, open your camera, dibuka kameranya semuanya biar kelihatan mukanya. Asraf sudah siap ya? Nanti di screenshot ya.
Baik, Ibu, sebentar.
Kita tunggu teman-temannya. Oke, open your camera please. Udah? Oke, nanti diambil per slide ya, Asraf ya.
Ibu.
Oke. Well, we will take for the first screen.
Satu, ya. Baik, sebentar.
The second screen. Okay, the third.
Masih slide 2, Bu, sebentar.
Oh, masih slide 2, oke.
Slide 2.
Mhm.
1, 2.
Oke,
Yang ketiga.
the third slide.
1, 2, 3. Yang keempat. 1, 2. Yang terakhir. 1, 2. Sudah, Ibu.
Okay, thank you very much for Asraf. Teman-teman. Okay, thank you very much for the participants. And now I will read a brief introduction about our speaker today. His name is Benjku Fabros from Victoria Tarlac, Philippines. And okay, he's obtained his Master of Science in Education from Central Luzon State University in 2021. And then he was graduated from Central Luzon State University for his bachelor from in 2019, and now he is an instructor in Department of Mathematics, Faculty of Science and Technology, Tarlac Agricultural University, Filipina. So I think that's all for the introduction, and now I will give the time for our speaker. So for Benjku Fabros, the time is yours.
Thank you so much, Kak Camila. So, mabuhay, greetings from the Philippines. Pagi yang indah, selamat pagi. Did I pronounce it right?
Selamat pagi. What should we say if you say mabuhay?
There's no direct translation, but it means long live, something like that.
Okay, so we just say mabuhay also? Or...
Yeah.
Okay.
And before we formally begin, I would like to virtually tour you and acquaint you to my beloved university, Tarlac Agricultural University. So let's watch these videos.
Tarlac Agricultural University prides itself as the first state college in the country to be converted into a university through the merit evaluation system of the Commission on Higher Education. We have also established our reputation as a center of development in agriculture education and as a center of excellence in teacher education. As of this academic year, we are serving about 5,000 undergraduate and graduate students from Tarlac and other provinces. Tarlac Agricultural University primarily provides advanced education, higher technological, professional instruction and training in the fields of agriculture, agribusiness management, science and technology, engineering, teacher education, non-traditional courses, and other relevant fields of study. It also undertakes research, extension, services, and production activities in support of the development of the province of Tarlac and provides leadership in its areas of specialization.
The best thing that I like most about TAU is the culture that it has, the accommodating people.
Looking at their hospitality and kindness, starting from the president to the student, they are all good to me.
I chose TAU because I know that this university has the quality education and
The qualifications of the faculty members here are high, professors here are highly qualified.
I believe that this university has the ability to cater the needs of the student, to impart me enough knowledge, wisdom, experiences, and opportunities in order for me to immerse myself not just within the university but also in the community as well.
Tarlac Agricultural University is a good place for me to study because I did agriculture in my secondary and I went to agricultural college. So I was actually found in a good place where they pursue solely agriculture, and I found Tarlac to be the ideal place for me to do my course.
Here in Tarlac Agricultural University, we students can develop our academic performance and also skills and talents through co-curricular and extracurricular activities. We can hone our interests also in dancing, singing, and journalism, and also you can join any organizations in our Tarlac Agricultural University.
TAU is known for its graduates in agriculture. In fact, our agriculture graduates are very much in demand here and abroad. Our education graduates also makes their names in various schools. Similarly, our veterinarians, genetic engineers, and IT graduates are very marketable.
I commend the Tarlac Agricultural University for its sustained efforts of promoting the students' welfare in providing conducive learning environment for them to develop their full potentials while celebrating their differences and their diversity in culture and traditions.
The values that I gained from Tarlac Agricultural University, it prepared me to be responsible in achieving my goals in the future. I believe Tarlac Agricultural University has a great factor in our life as a professional right now.
We at TAU remain committed in harnessing, developing, and catalyzing conversion of the full potentials and capabilities of the students into becoming responsible and competent professionals in agriculture and allied disciplines, anchored in our core values: integrity, excellence in service. We shall realize our vision in universities in Asia.
Okay, that's the virtual tour of my beloved university. And if time permits, I wish to welcome you here face to face. So now to formally begin, I would like to share my screen. By the way, am I audible? For a while.
Is it okay? Okay.
Can you see now my screen?
Yeah, okay. You can see.
Thank you, Kakak. So, okay, so to formally introduce myself, I am Benchgo Fabros, faculty from the Science, Mathematics, and Technology Education Department, College of Education, Tarlac Agricultural University, the Philippines. So let's start. So today we will be dealing on mathematics education class. To be specific, the differential calculus. So what will be the content of our lecture today? So today we will deal on derivatives. To be specific, the definition and the differentiation. Sure. So I hope you are ready, and let's make our discussion more interactive. So later on, I'll ask questions and then you will give the answer. So let's now talk derivatives. So when studying differential calculus, it is all about derivatives. So when we say derivatives, it is the heart of differential calculus. So the process of finding the new function of finding the derivative is what we call the differentiation. So guys, in calculus, differentiate means finding the derivative. Instead of the English word that we know na that mean compare or contrast. So when talking about differential calculus or derivatives, when we say differentiate, it is finding the derivative, not the English word to compare or to contrast. So is that clear? Okay, let's continue our discussion. So technically speaking, what do we mean by derivative? So by definition, when we say derivative or f prime of x of any function y is equal to f of x, we define derivative as f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches to 0. So provided that the limit exists. So if it is exists, we say that your f of x is differentiable at x. So that's the technical definition of derivative. So next, so we have here a remarks. It says here that the derivative or our notation for derivative is f prime of x is now a new function, different but obtained accordingly from a given function f of x. If we have the function f of x, then if we're going to find the derivative, then our new function is the f prime of x. So if we see this notation, we mean derivative or the output of your derivative. Later on, we will see that. So there are differentiation theorems that facilitate the process of finding derivatives. Later on, we will talk the different theorems that will help us in dealing derivatives. So these theorems are helpful to us, most especially if our goal is to have a successful differential calculus journey. Now, the discovery of calculus is often attributed to two men, so who are independently developed its foundation. Now, the question is, who are those two men? So these are the derivative symbol f prime of x is said to be the notation of Sir Isaac Newton of England. Without loss of generality, we also sometimes use f prime or y prime. So who are the other man? So on the other hand, Sir Gottfried Wilhelm Leibniz of Germany used the notation dy over dx or df over dx. So these are the two notable person when it comes in derivatives because they are hailed as the father of calculus. Okay, the two notation, of course, they have also their own advantages. That's why in learning differential calculus, we often use them interchangeably. So there are times that we use the notation of Sir Isaac Newton of England, and also there are times we will use the notation of Sir Gottfried Wilhelm Leibniz. So these are the two men that when you say calculus or derivatives, they attach to it. Okay. So now let's talk about the differentiation theorem. So as mentioned a while ago, the derivative is the heart of differential calculus. So without being able to differentiate correctly, you cannot progress with calculus as a whole. So we now discuss the differentiation theorem, which will make finding derivatives quicker and easier. So always remember that, guys, that differentiation theorems will help us in dealing calculus or derivatives quicker and easier. So now let's talk about the theorem number 1. So it says here that in theorem number 1, if f of x equals c, where your c is a constant, then your derivative or f prime of x is equal to 0. So in simpler manner, the derivatives of any function, any constant, I repeat, the derivative of any constant is always a 0. So is that clear? That the derivative of any constant is always a 0. So let's have an example to more appreciate the theorem 1. So we have example 1, f of x equals 7, g of x equals 3 over 4, h of x equals 3 pi, f of x equals e squared, and g of x equals 5 pi minus 3. Now let's answer using theorem 1. So f of x equals 7. What is the derivative of f of x equals 7? So if you want to answer, you may raise your hand or you just simply type in the comment section. So remember that our theorem 1, it says that the derivative of any function is always what? So they think, what is the derivative of function 7? F of x equals 7. It is correct. It is 0. So as you also notice, we use now the notation of derivative. So this means that we have done in the process of differentiation. So next sample, g of x equals 3 over 4. What is its derivative? Pritali is raising her hand. Or you just make your hand something like that.
No, yeah, I did raise my hand. I think the differentiation from gx 3 per 4 is same with number 1. I think it's 0.
Okay, correct.
It's
Because 3,
it's also
4,
a constanta.
a constant, correct.
Yes,
So thank
thank you.
you, Pritali. So how about our third example? H of x equals 3 pi. Anyone who wants to try to answer? So guys, one of the challenges in mathematics, most special to us teacher, is the student is shy to answer because they are afraid to give the answer correctly. But always remember, guys, that that's the essence of learning, is to learn. Even if it's wrong, at least you have tried. So anyone who would like to try this one? Ali, Ahmad?
Okay, thank you for the chance. I think the answer is still 0 because pi is still constant. It has
Okay,
a value.
correct. So pi is a constant. That's why when you multiply two constant, it's also a constant. So correct. So guys, do not forget to use the notation of derivative in getting your answer, because sometimes student fail to put that. They also put h of x instead of h prime of x, because this denotes a derivative. How about this one? F of x equals e squared. What do you think, guys, is the answer? F of x equals e squared. So we are now getting to our previous knowledge in our previous years. So what my teacher taught me about the E. Okay, let's reveal the answer. Maybe you are shy, but later on you will conquer that. So E squared is also a 0 because E is a constant. And lastly, 5 pi minus 3. What will be the derivative of 5 pi minus 3? So it is also a 0. So guys, is theorem number 1 clear to you? Okay, silence means yes. So thank you very much. So always remember that a derivative of any constant is 0. So that's theorem number 1. Now let's proceed on discussion of theorem number 2. So what is theorem number 2 all about? It says here that if f of x equals x raised to n, or x to the power of n, where your n there is a fixed constant, then if you're going to find the derivative of that, we will have f prime of x equals your n multiplied to x raised to n minus 1. So as you can see here, to get the derivative of the n power, so the exponent n becomes a coefficient. So you can see here, it becomes the coefficient, and then we will less 1 on the power. So n, and then we will less 1. So that's the process of theorem number 2. So the exponent n becomes the coefficient, but leaves the exponent with 1 less, which is n minus 1. So for us to more appreciate that theorem, let's have an example. So these are some examples, but let's answer that. So it says here, f of x equals x. So in order for us to utilize theorem number 2, it says here that the power or the exponent becomes a coefficient, and then we will less 1. So what is the coefficient of x here? It is 1. So it becomes, when we find the derivative, so the 1 there, it becomes a coefficient, and then we will less 1 from the original 1. So 1 multiplied to x raised to 1 minus 1. So did you see the pattern? And then we will now simplify. So what is x raised to 1 minus 1? It is x raised to 0. And what do you mean by x raised to 0? In our law of exponent, it is simply 1. So our final answer here is 1. So let's have another example. This one. So g of x equals s cubed. So what will be the process? The 3 becomes coefficient, and then we will less 1 to the 3. So it becomes 3s cubed minus 1. And then s cubed minus 1 will become s squared. So our final answer is what? the derivative of g of x equals s cubed will become now what? Anyone? So you may tick the raise hand button, or you just simply use our chat box. Okay, so the answer will be 3s squared. Oh, correct. How about this one? H of x equals t raised to 31. So the same algorithm. 31 becomes your coefficient, and then we will less 1 in 31. So the derivative of h of x will become 31t raised to 30. So did you get how to use the theorem number 2 now? Okay, so how about this one? Let's integrate our example. F of x equals 1 over x. So for us to have a simpler calculation of derivative, of course, we need to simplify things in its simplest form or into another form. So 1 over x is also what? It becomes 1 over x becomes x raised to
-1.
-1 or -1. So that's correct. So now it looks familiar, and then we will now use the theorem number 2. We will make the -1 as our coefficient, and then we will less 1. So it becomes -1 x raised to -1 minus 1. So what will be now our final answer? So what will be our final answer? Negative x raised to -2. But this one, negative x raised to -2, can be simplified also. This will become what? 1 over -1 over x squared. So how about this one? Okay, so we need to simplify things if it's possible, and then we will now proceed to the process of differentiation. How about this one? G of x equals square root of x. So what will be the other form of square root of x? It is x raised to, your index is 2, right? And then the power of your x here is 1. So it becomes x raised to 1/2. Then we will now proceed to the differentiation. So it becomes 1/2 times x raised to 1/2 minus 1. So 1/2 minus 1 is what? Negative 1/2. Then our final answer will be 1 over 2 square root of x. So is that clear, guys? Okay, so thank you very much. Now let's proceed on theorem number 3. So what is theorem 3 all about? So in theorem 3, it says here that if f of x equals your c or your constant c multiplied to your g of x here is a function, then your differentiation will become you multiplied your constant to the derivative of your function. So c times the g prime of x. So in a simpler manner, the numerical coefficient c is left untouched. We just do the derivative of the accompanying function. So let's have an example for us to appreciate our theorem number 3. So we have here 5 examples. So let's try to answer number 1. F of x equals 3x. So it says your constant will left untouched, and then the accompanying function, you will proceed to differentiating it. So let's extract first who is the constant and who is the function. So who is the constant here? Or what is the constant
3.
here? It's 3. And the function is x.
X.
So in finding the theorem number 3, so the coefficient is left untouched. So, and then we will find the derivative of x. So what is the derivative of x? So 1 minus 1 or x raised to 0. So what is the final answer for the function f of x equals 3x? It becomes 3x raised to 0 or simply 3. Okay. How about this one? Pi s cubed. Pi s cubed. Now, the first step, of course, we will determine first who is the coefficient and who is the function. But in this case, our coefficient is pi, or the constant here is pi, I mean. And your function is s cubed. So now, let's answer. So s cubed, we will make the power of 3 the constant, and then we will less 1. That's why 3s cubed minus 1, and then your constant is left untouched. And let's simplify. It will become 3s squared pi. Or it can be pi 3s squared, 3 pi s squared. That's okay, because always remember that a multiplication is commutative. So regardless of their position, it's okay. So let's have our third example, negative 4s squared. Anyone who would like to try? Maybe this time you overcome your hiya. In Filipino we call it hiya, but in English it's afraid or shy, something like that. So anyone who would like to try in finding the derivative of negative 4s squared? Or maybe you're still shy. Okay, so let's answer, by the way. It becomes, so maybe this time some can mentally answer this one, but some can still go on to the step-by-step process, but it's okay, guys. Let's try to answer this mentally, and then we will later on reveal if it is correct. This will become negative 4 times 2, because the 2 will become coefficient, and then we will less 1. So it's become s raised to the 1. So in final answer, the final answer will be negative 8s. Did you get that? So let's show the process. Okay, so your 2 become coefficient, and then you will going to multiply it to the constant. And then negative 4 times 2 is negative 8, and then the power of 2 less 1. It says on our previous theorem, 2 minus 1, it becomes s raised to 1, or simply s. So h prime of x equals negative 8s. Is that clear? Okay, so thank you so much for your response. Let's have our fourth example. Now, this one, 31 over x. So again, for us to get the correct answer, we can just simplify things. 31 over x becomes what? It will become 31 raised to negative 31 x raised to negative 1. So this will be the simplification. So now let's proceed in finding its derivative. So become, we can mental it now. 31 times negative 1 times x raised to negative 1 minus 1. Or negative 31x raised to negative 2. In final answer, negative 31 over x squared. How about this one? 3 square root of 2. 3 square root of x. 3 square root of x. So we just simplify square root of x. So it will become 3x raised to 1/2. And then we will now go on to the process. It will become 3 multiplied to 1/2, and then x raised to 1/2 less 1 minus 1. So it will become 3/2 x raised to -1/2. Let's simplify that. It will become 3/2 square root of x. So is that clear, guys? Okay. So now we are done on discussing the first 3 theorems. Let's now proceed to the fourth theorem. Our fourth theorem goes like this. If f of x equals f of x plus minus, so this can be an addition or this can be a subtraction of g of x, then your derivative will become the differentiation of your function f plus minus the derivative of your function g. So it means the derivative of a sum is the sum of the derivatives. So we differentiate each term separately. Is that clear? We differentiate f of x and g of x separately. So it's just like a combination of your previous theorem. So let's have this example. Okay. Let's try to answer. Number 1, this one. F of x equals 5x minus 16. So your first function is 5 of x, and then your second function is 16. So in order for us to utilize theorem 4, we differentiate 5x and 16 separately. So what is the derivative of 5x? It's just simply 5. And differentiation of 16, what is the derivative of constant? It is 0. So it becomes 5x raised to 1 minus 1 minus 0. Or simply 5 times x raised to 0, or simply 5. Is that clear? How about this one? Let's try this one. X squared minus 7x plus 13. So we have 3 functions here. So these 3 functions, the x squared, 7x, and 13, we differentiate them separately. So how are we going to do that? What is the differentiation of x squared? It is 2. The 2 will become coefficient, and then we will less 1. 2x raised to 2 minus 1 minus 7x raised to 1 minus 1, and then your constant is 0. So let's simplify. 2x raised to 1 minus 7x raised to 0. So our final answer will be 2x minus 7. So is that clear? So always remember, in theorem 4, we will differentiate them separately. So let's have our third example. This one. S, the quantity of s minus 2 cubed. So how are we going to answer that one? So in our algebra class, we are taught to expand the functions or expressions or terms, right? Just to remember the process. Sometimes they call it the FOIL method. First, outer, inner, and last. But this time, s minus 2 cubed means s minus 2, s minus 2, and s minus 2. Now, let's expand this expression. S minus 2 cubed. So it will become, using the binomial theorem, it will become what? It will become s cubed minus 6x squared plus 12s minus 8. Now, if we expanded our function now, we can now proceed to the theorem. So we have here 4 functions. So we will differentiate now these 4 functions separately. The derivative of s squared, the derivative of 6s squared, derivative of 12s, and derivative of negative 8. So it becomes like this. 3s cube minus 1 minus 6 times 2 s raised to 2 minus 1. And then the 12s, 12 times s raised to 1 minus 1. And then your constant, 0. Let's simplify. 3s cubed minus 1 will become 3s squared. And then 6 times 2 times s squared minus 1 will become negative 12s. And then 12 times s raised to 0 is simply 12. So this will now our final answer for the function quantity of s minus 2 cubed. So we will just simply expand this one in order for us to come up in this final answer. How about the fourth one? 3x minus 2 over x. So this one now is a rational function. So we are now dealing to a function, rational function. So what will be our process in getting that? So we can separate this one because 3x minus 2 over x also mean 3x over x minus 2 over x. We just distributed your denominator x. So it will become 3x over x minus 2 over x. And what is 3x over x? Simply 3. We will now cancel or eliminate x. And then your new function now will become 3 minus 2x raised to negative 1. And now the function now is look simpler. We can now proceed in differentiation. So what is the differentiation for constant? It is 0. And then differentiation for 2x raised to negative 1. Negative 2 times negative 1, x raised to negative 1 minus 1. Our final answer will be 2x raised to negative 2 or 2 over x squared because of the law of exponent, specifically the negative exponent. Okay, so is that clear? Guys, can I hear your voice? If it is clear?
Yes, sir, it's clear.
Okay, thank you so much, guys.
Yes.
Now let's have our last example. This one. Let's try this one. G of x equals x cubed over 3 plus 2 over x squared minus x. So let's try, or let's integrate, or let's have a complex one. How are we going to answer this one? We will make this rational expression or function to, we will simplify this one. It will become 1/3 x squared, x cubed I mean, plus 2x raised to negative 2 minus x. So it's now the combination of our previous theorems. So let's answer this one. So 1/3 times 3 and then x cubed minus 1 plus 2 times negative 2 times x raised to -2 minus 1 minus x raised to 1 minus 1. So it may look like laborious or vague, but if you're going to recall the process, you're going to answer that step by step, it will be just a piece of cake. So let's simplify things. So it'll become 1/3 times 3 is 3/3, and then 3 minus 1 is x squared. 2 times -2 is -4. And then -2 minus 1 is simply -3. And then 1 minus 1 is 0, simply -x raised to 0. So 3/3 will become 1. So x squared minus 4/x cubed minus 1. So guys, do not forget to include the x raised to 0 as 1, because sometimes students think that x raised to 0 is equal to 0. That's why they forget to put the 1 here. You will become wrong. Your answer becomes wrong if you forget to do that. So this will be our final answer. And if we're going to simplify this one, we will get their common LCD. So that's x cubed. And then if we're going to simplify, it will become x raised to 5 minus x cubed minus 4 all over x cubed. Okay, so that's our final answer. But if you arrive in x squared minus 4/x cubed minus 1, it is also correct. But in simplest form, or sometimes your professor or your teacher will order you to get the simplest form or the final form. So this one is the final form. Is that clear? So far, so good?
Clear, sir.
Yes, thank you so much. So now let's have theorem 5. So we are about to go to our, we have actually 7 theorems. So we're almost on the end. So in our theorem 5, it's on multiplication. So your function f of x equals your function f multiplied to the function g, g of x. Then you just differentiate them separately also. But the derivative of a product, this one, the theorem 5 is what we call the derivative of product, because we are in the operation is multiplication, or we will get the product. But remember that the derivative consists of 2 terms. Your 2 terms here is the function f of x and the function g of x. So in finding their derivative, one and only one of the factors is differentiated. And the derivative of a product is not the product of the derivative. So what I mean of that? So in finding this one, later on, we will appreciate what I'm saying. So let's show first the example. So we have 3 examples here. This one. So let's try this one. F of x equals pi x cube. So just like what we did on our previous example, we will determine first your function. So the first function is pi, and the second function is x cubed. So it says here that the derivative of a product is not the product of the derivative. So what I mean to that? So meaning to say, if we're going to find the derivative of a product, we will get first the derivative of the first function, and then we will multiply the second function, and then we will add, and then the second function, the derivative of the second function, and then multiply to your first function. Did I make myself clear to that? I will repeat. So in finding the derivative of a product, you first find the derivative of your first function, and then you will multiply the second function. So it's just simply the derivative of the first times second. What I mean to the first and second, the first function and the second function. And then you will add the derivative of the second times the first function. Just like what we did here. So your first function here is pi. Second function is x cubed. Derivative of the first or derivative of the pi is 0. And then multiply the second. And then we will add derivative of the second, 3x 3 minus 1, and then we will multiply the derivative by the first function. So derivative of the first times second plus derivative of the second times the first. Is that clear? The process is clear? So let's simplify. 0 multiplied to x cubed is simply 0. And then pi multiplied to 3x squared will become 3 pi x squared. This is clear? Number 1 is clear? First example is clear? So let's have
Yes,
another
it's
example.
clear.
Let's have another example. So this one, we have g of x equals 3x minus 2 and then 5x plus 3. So we're going to answer that. We will simplify first. 3x minus 2 and then 5x plus 3. So if you did this one, 3x raised to 1 minus 1 minus 0 times 5x raised to 1 minus 1 plus 0. So what will become that? If you simplify, 3x raised to 0, 5x raised to 0, or simply 3 times 5 or 15. So if you did this one, your answer is incorrect. Okay? So do not be confused to that, because some student, one of the misconceptions or common errors of a student, when they see this kind of a function, they just simply find the derivative of 3x, find the derivative of 2, find the derivative of 5x, and find the derivative of 3. But always remember, guys, what I've said a while ago, that the derivative of a product is not the product of the derivatives. So how are we going to find the derivative of that correctly? We'll just simply simplify 3x minus 2 to 3x minus 2 and 5x plus 3. How are we going to do that? We will, it becomes 15x squared minus x minus 6. How did we get that? 3x times 5x, 3x times 3, negative 2 times 5x, negative 2 times 3. The process of FOIL method. Is FOIL method also used in Indonesia? Or do you have any term for that? Because in Philippines, we use the FOIL method. The first, outer, inner, and last. May I hear your answer? Is FOIL method also used in Indonesia, or do you have any term for that?
Yes, we use the same method, but I don't think there is any special name for it.
Oh, okay. Thank you for that, Ali. So this one. Now we can now proceed to finding the derivative. So derivative of 15x squared is 30x. Derivative of x is negative 1. Derivative of negative 6 is simply 0. So our final answer is what? 30x minus 1. So maybe this time you can mentally answer our derivatives. So that. How about this third example? So we have here the quantity of x minus 2 cubed. How we're going to find that one? So we know that the quantity of x minus 2 cubed is 3 terms. S minus 2, S minus 2, and S minus 2. But if you did this one, you find the derivative of S and find the derivative of 2, this one, s raised to 1 minus 1, and then minus 0, or s raised to 0 minus 0, or 1 minus 0 cubed, or 1 cube, or simply 1, if you did this process, then your answer is also incorrect. So also remember that, guys. So what we're going to do is we will expand this one, s minus 2, s minus 2, and s minus 2. So it become like this, s minus 2, s minus 2, s minus 2. Because we know that s minus 2 cube is s minus 2 3 times. S minus 2, s minus 2. So this one, the derivative of the first times second and third plus derivative of second times first and third plus derivative of third times first and second. So that's the process. So what did you notice, guys? This one, we have now 3 functions. So in dealing the derivative of a product, so whether it is 2 functions, 3 functions, or n function, the process still the same. So this one, the derivative of the first is simply 1, and then we will multiply the second and third function plus the derivative of second function is 1, and then we will multiply the first and third function. And then plus the derivative of third function, which is 1, and then we will multiply the first and the second function. So that's the process. And then we will simplify. So 1 times s minus 2 times s minus 2 is just simply s minus 2, s minus 2. As well as the second term, s minus 2, s minus 2. And the third term, s minus 2, s minus 2. So let's simplify this one. This will become s minus 2 times s minus 2 is also s minus 2 squared. Same goes to the second and third term. Now, s minus 2 squared plus s minus 2 squared plus s minus 2 squared is what? They are, what is the rule here? If we have the like terms, we have like terms here. So we'll just simply add the coefficient. The coefficient is 1, and then we will just copy the like terms. So the like terms here is s minus 2 squared. So 1 plus 1 plus 1 is 3. So it will become 3 multiplied s minus 2 squared. So is that clear, guys? Okay, so thank you. So that's our theorem number 5. So far, so good. Can I have a heart react so that I'll know that you're still there?
Good, sir.
Okay, thank you so much. So let's continue. So we have our next theorem. Theorem number 6. So in theorem number 6, if f of x equals f of x all over g of x, then your function becomes g of x times the derivative of your f of x minus f of x times the derivative of your g of x all over g of x squared. So it may be it look like challenging, but later on we will I will give you a tip on how to answer this easier. So we have here 2 examples. So in here, theorem 6 is known also as differentiating a quotient of 2 functions. So the 2 functions are f of x and g of x. So let's try to answer number 1. So it says here, f of x equals 3x plus 8 all over 2x minus 5. So we will have 3x raised to 1 minus 1 plus 0 all over 2x minus 1, 2x raised to 1 minus 1 minus 0. So it becomes 3 raised to x raised to 0 all over 2x raised to 0. So your final answer is 3 over 2. So if your process is like this, then I must say that your answer is incorrect. Because in theorem number 6, the process is not simply taking the derivatives of the numerator and the denominator separately. So it's not like that. We will not find the derivative of the numerator and the derivative of denominator. The process of differentiation of quotient function is not like that. But before we go on to in finding the solutions or the answer in question number 1 in the right way, I will give you first the tip on how you will recall or use the theorem number 6 easier. So we know that the derivative of f of x all over g of x is g of x times the derivative of f of x minus f of x times the derivative of g of x all over twice the g of x, or g of x squared. So instead of its more complicated process, we will drop the x part or the independent variable x. So it will become your function f over g. And then the derivative is g times f prime minus f times g prime and then g squared. So for some, it's okay for them, but we can actually make this simpler, even more simpler. So how? We will add a rhyme. So we will make your f as the high part because it's in the high or top part, and then the g part is in the low part or the low. So we will make f equals high over low. So we will put rhyme for you to recall easier. So high over low. And then if you're going to find its derivative, it will become low multiplied derivative of high minus high times the derivative of low over low or low squared. So what rhyme is that? Low de high minus high de low over low. So can you say that? Low de high minus high de low over low. So that's the process. So if you remember that easier, then you can answer the theorem 6 easier. So can I hear you saying that? Low de high minus high de low
Low de high
over
minus high de
low
low over low.
or low squared. So it looks simpler now. So high means your numerator, low means your denominator. So low de high minus high de low over low. So let's answer now the first question. 3x plus 8 over 2x minus 5. So what's the process? Law. What is the law here? 2x minus 5. And then the high, derivative of high. What is the derivative of high? What is the derivative of 3x plus 8?
3.
3. And then what's next? Minus. What's the process? Minus
High derivative of low.
Derivative of low. So this one. So low, 2x minus 5, and then derivative of high minus. So guys, in on the second function, I encourage you to use bracket to limit or to because sometimes student use the negative here as the sign of the second function, but that's not the case. The negative here will be distributed to your entire second function. So that's why I am encouraging you to put bracket or braces. And then let's continue. Lodi high minus high de lo over lolo. So let's simplify. 2x 3 raised to 0 minus 3x plus 8 times 2x raised to 0 over lolo, 2x minus 5 squared. And then let's simplify 2x minus 5 from 3x raised to 0 and also 3x plus 8 from 2x raised to 0. It will become 2x minus 5 times 3 and then 3x plus 8 times 2. And then we'll simplify 2x minus 5 times 3 will become 6x minus 15. And then 3x plus 8 times 2 becomes 6x plus 16. And then 2x minus 5 is squared. And then let's continue. We will now distribute this one, the negative, to your second function. That's why I'm encouraging you to use the bracket or the parenthesis or that one. So we will now distribute. It will become 6x minus 15 minus 6x minus 16 over 2x minus 5 squared. And then we will simplify the high part. 6x minus 15 minus 6x minus 16. What will be the answer? Anyone? Again, I want to hear your voice, sweet voice. Who wants to try this one? The high part. Who would like to try? Ali is smiling. Maybe you want to answer. Maybe Ali is enjoying the discussion. Do you want to try, Ali? So what is the answer for 6x minus 15 minus 6x minus 16? It can be like this, 6x minus 6x minus 15 minus 16, for us to see who are the like terms and not. So 6x minus 6x is simply 0. Minus 15 minus 16 is negative 31. And then we will copy 2x minus 5 is squared. So that is our answer for question number 1. So the process is quite long, but since we have in mind the Lodi high minus high low over lolo, it's more simpler. So let's try the second example. Is our first example clear? Okay, so thank you.
Yeah.
So let's have our second example. This one. 1 minus 2x all over 5x minus 2. Again, we will use the Lodi high minus high low over lolo. This one. So law 5x minus 2, and then derivative of high is negative 2. Minus high 1 minus 2x, derivative of law is 5. And then all over 5x minus 2 is squared. Let's simplify. 5x minus 2 times negative 2 is negative 10 plus 4. And then 1 minus 2x times 5 is simply 5 minus 10x. And then copy 5x minus 2 is squared. And then now we will now distribute the negative sign here to the entire second function in the high part, or the second term. So it will become negative 10x plus 4 minus 5 plus 10x. And then simplify this one. It will become negative 10x plus 10x is 0. Positive 4 minus 5 is negative 1. All over 5x minus 2 squared. So that is the answer for example number 2. Is it clear? Is it now more clear? Is it clearer? So
Yes, that's clear, sir.
So that's the that the tip or technique on how to become or on how to ace mathematics. You just keep on practicing. Practice makes perfect in mathematics. Because we are also human. We commit mistakes, but if we kept on practicing, we will develop that skill. So let's have our third example. This one. H of x equals 2x squared minus 8 all over x plus 2. So we're going to answer that. So guys, what I have said in our previous theorems, if your function can be simplified, or if possible to be simplified, then you may do so. But if it's not, then we will not proceed to the process. But in this case, do you think it can be simplified? What do you think, guys? It can be or it cannot? It can. 2x squared minus 8 becomes okay, I will now reveal. But before we use that one, the simplification, sometimes students forgot to simplify. They often use as is. But let's try that one, as is first, before the simplified one. So, law di high minus high di law. Law, x plus 2, derivative of high, 4x, minus high, derivative of law, which is 1, over law. Let's simplify. X plus 2 times 4x is 4x squared plus 8x. And then 2x squared minus 8 times 1 is simply 2x squared. And then distribute the negative sign. Negative times negative is positive. And then all over x plus 2 is squared. Let's simplify the upper part or the high part. 4x squared plus 8x minus 2x squared plus 8. Becomes 2x squared plus 8x plus 8 all over x plus 2 squared. Let's simplify. So 2x squared plus 8x plus 8 can be simplified because we factor it by 2. So factor it by 2 and then multiply x squared plus 4x minus 4. Why we factor this one? Because we have in mind that we can use the denominator to eliminate the numerator, because x squared plus 4x minus 4 is x plus 2 squared. And we can now eliminate to x plus 2 squared. So our final answer is simply positive 2. So that's the process. If you forget to simplify your function. But how's the process if we simplify it in the first place? Let's check if we will have the same answer. So our original function is 2x squared minus 8 all over x plus 2. If we're going to simplify this one, 2x squared minus 8 becomes 2 times x squared minus 4. And then we know that x squared minus 4 is x plus 2 and x minus 2. Is my algebra correct?
Yes. I think it's correct.
If in case I put incorrect, you may correct me, because sometimes when you are tired, especially as students or even teachers, we type differently. Our gadgets also tired. That's why they type it incorrectly. So this one, 2 times x plus 2, x minus 2. And then we can now eliminate x plus 2. So 2 times x plus 2. And then we will distribute 2. It becomes 2x plus 4. And then if we find the simplest form, that's the time we will now proceed on finding its derivative. So what is the derivative of 2x plus 4? It is simply 2x raised to 1 minus 1 plus 0 or 2. Do we have the same answer? Yes, we have the same answer, but different process. So which one is easier? The one that you don't simplify or the one that you have simplified? So it's up to you. It's your preferences. So I just show to you the different process or different way on how to find the answer in this kind of problem. Okay, so is that clear, guys? Am I making myself clear to this?
Yes, sir. It's clear. It's understandable.
Okay, thank you. Now let's have theorem number 6. So what is theorem 6? Or I mean the theorem 6.1. So if f of x equals ax plus b over cx plus d, where your a, b, c, and d are constant, with c and d are not both zeros, then your derivative will become ad minus bc all over cx plus d squared. So this one, theorem 6.1, is a corollary, or the theorem. When we say corollary, guys, it is a theorem that follows on from another theorem. So how are we going to use this one? The ax plus b over cx plus d, and then it will become ad minus bc all over cx plus d squared. So let's have an example. So guys, this means theorem 6.1 that the derivative of f of x ax plus b over cx plus b cx plus d can easily be found by subtracting the cross product. So this one, cross product, I mean AD, BC, and then you subtract AD minus BC. The cross product of AD and BC of the coefficients, and then squaring the denominator. That's the process. So cross product AD, BC, and then squared of your denominator or the low part. So let's answer the following examples. So let's have number 1. G of x equals 1 minus 2x all over 5x minus 2. So this one, some student applied theorem 6.1 instantly, as is. They applied this one. So, and then coming up to an incorrect answer. Why? Why I said that? Because our form is ax plus b over cx plus d. So we will arrange first and pattern to that form. Now my question is our first example is already in pattern to the form?
Not yet.
Not yet. That's the first step. We will arrange it before we go on answering. So it becomes negative 2x plus 1 all over 5x minus 2. Is that clear? So you need to first check if the question is already patterned to your theorem. If not, then rearrange. Then if yes, you may proceed already. So this one, let's apply the AD minus BC. What is your A here?
Minus 2x. Negative 2x.
It's negative 2. And what's your C here? I mean, when we say ABC, we are talking only on the coefficient or the constant. That's why -2 instead of -2x. But I think let's try again. What is your A part here? It's -2.
-2.
How about the D part? AD minus BC. So A -2, D -2 minus your B 1 and your C 5. AD minus BC. AD minus BC. And then all over the squared of your denominator. So -2 times -2 is +4 minus 5. 4 minus 5 is -1 all over 5x minus 2 squared. So this is our final answer. But guys, this 1 minus 2x all over 5x minus 2, you can actually use our Lodi-High minus Heidi law over Lolo also to counter check if they have the same answer also. So is theorem 6.1 clear here on how we use it? So you need first check if it is in the form of ax minus bc over cx plus d. If no, rearrange. If yes, proceed. And then second, the step is you need to determine first your A, your B, your C, and your D correctly. Because if you didn't determine that correctly, then your entire process or your final answer will become or will be incorrect. Now, is that clear, guys? Is example 1 is clear? Okay, thank you. So let's have another example. So we have example here, h of x equals x squared minus 2 all over 2x plus 3. So do you think what will be the answer? Let's check first if it is in the form. Second step, we will know the ABCD. So 1 times 3 minus -2 times 2, and then squared of your denominator. 1 times 3 is 3, minus -2 times 2 is +4. So our final answer is 7 over 2x plus 3 squared. So now my question, guys, is if you agree that this is the answer, you may react a heart sign. Do you agree that this is the answer? What do you think, guys? Is this the do you agree? Oh, what is A? A is 1, D is 3, B is -2, and C is +2. 1 times 3 minus -2 times 2, and then it says that cx plus d, or your denominator, will become squared. So 3 plus 4 is simply 7, and then 2x plus 3 is squared. Now my question is, do you think, guys, is our answer here is correct? If you agree, you may react a heart button. And if not, what do you think will be the answer? What do you think, guys? Something like that. You are thinking now. Camila, are they all first year?
Yeah, all of them are from the first year.
What do you think, guys? You're still answering? Any guess? Any wild guess? Because sometimes if we don't know the answer, we just simply guess. That's the most, especially if we are dealing with a multiple choice. If we don't know the answer, we just simply guess. But this time, do you think? Any guess if you are not sure with your answer? Do you think our final answer is correct or not? I'm just confirming if you really understood the theorem 6.1 before we go on. Do you think,
I think
guys?
someone write in chat box. You can check, Benj.
What did So based from Muad, Hadi, don't think so because of this. May I hear your voice? What's the name again? I'm having a hard time remembering the names. Muad. Am I pronouncing it right?
Because of the square, I think you're gonna have to put 2 next to the x.
So if how we're going to do that? If we will put squared on what? On 1?
And instead of saying 1 times 3, we could say 2 times 3 because
2 times 3.
yeah.
So it becomes 2 times 3 is 6. 6 plus 4 is 10.
Yeah.
Am I right? So let's say Muwad, let's say this is 10. Do you now agree, guys, that our final answer is 10 over 2x plus 3 squared? What do you think?
I think
Still
something is
no,
missing.
still no idea.
I don't think
It's
so, sir.
missing.
I think we can't use AD minus BC formula here because I think it's AX plus B over CX plus D. So it has to be X. It can't be X squared. So I don't think we can use this formula.
Okay, very good. How do you say this? That's a good. How do I notice? Or what is the right word for notice? Can you help me in finding my right word or right term? Very good observation, Ali. So we can't use theorem 6.1 here because theorem 6.1 is only applicable to the linear function. But in this case, our example is in the power of 2, and power of 2 is a quadratic function. So is that clear? We can only use because they neglected the power. They just simply use theorem 6.1 right away. So always remember, guys, that theorem 6.1 is only applicable and can be utilized if your function is in linear form, meaning to say the highest exponent is 1. But in this case, it is a quadratic function, or the highest exponent is 2. So this is an incorrect answer, or it is wrong. Instead, we will use the Lodi-High minus High-Day law over Lolo. So is that clear now? I hope if it is clear, you can now make a heart react. Okay. Thank you so much, Ali, for pointing out that one to the group. So let's answer that one in Lodi-High minus High-Day law over Lolo. So law, 2x plus 3, derivative of high, 2x, minus high, x squared minus 2, derivative of law, 2 over Lolo. So become 4x squared plus 6x minus 2x squared minus 4. And then we simply distribute the negative sign here. It becomes 4x squared plus 6x minus 2x squared plus 4. And then we will simplify 2x squared plus 6x plus 4 all over 2x plus 3 squared. So that's now our final answer. How about this one? Final example for theorem 6.1. 3s minus 2 over s. Now, let's go back to the tip that I gave earlier. Let's check first if it is a linear or not. Is it a linear? Yes or no? It is, because the highest exponent is 1. Now the question is, and if it is linear, then we can use theorem 6.1. The next question is, it is already in the form of our theorem. Yes, it is. If that is the case, then we can now proceed on answering and using the AD minus BC over CX plus D squared. Now the question now is, what is A, what is B, what is C, and what is D? That's now the question. So A is 3. D is 0 because there's no D there. That's why 0. Minus B is -2. And then your C is 1. And then over squared of your denominator, which is S squared. And then now, 3 times 0 is 0, minus -2 times 1 is +2. So 2 over S squared. So that's our final answer. So is that clear? Okay, so now let's proceed to the last theorem, which is theorem number 7. So in theorem number 7, if f of x equals the function of u of x, where f and u are differentiable functions of x, then we will get the derivative by getting the function of u of x multiplied the function of u prime of x. So we have a corollary here. Based on this theorem, we will have our corollary if f of x equals f of x raised to n, where n is an element of a real number, r, then the derivative of this function is simply your n becomes the coefficient, and then your function f of x raised to n less 1. And then you will multiply the derivative of f of x. Now, what did you notice on this? They are somewhat similar to our second theorem. Do you still remember our second theorem? X raised to n, and then n times x raised to n minus 1. They are somewhat alike. They are somewhat alike, but the difference, by the way, theorem 7 and corollary is what we call the chain rule. Chain rule. So what is chain? So it's like a continuous or a function of a function, something like that. So this is our last theorem is a chain rule. It is about differentiating chain of function, which is a function of a function. So like what I've said earlier, that they are the theorem 2 is somewhat alike in the chain rule, but their difference is that your chain rule involves an nth power of a function. I repeat, nth power of a function. But the theorem 2 only involves simple n power or the nth power of your x. Chain rule, nth power of a function. Theorem 2 function involves n power of x, a function and an x. So let's have our 3 example here. So how we use this one, and always remember remember guys that chain rule is commonly used and oftenly used in dealing higher derivatives or higher math problems. So that's why it is important to understand chain rule. So how are we going to use chain rule? So let's have example number 1, s minus 3 raised to 3. So it says here in the chain rule, your exponent, it will become a coefficient, and then we will less 1 to the function, this one s minus 3, and then multiply to the derivative of your function s minus 3. How to do that? So it will become 3, and then 3 minus 1, and then the derivative of s minus 3. So it will become 3 times s minus 3 squared times s raised to 0 or 3s minus 3 squared times 1, or simply 3 times s minus 3 squared. Okay, so that's how chain rule works. Sometimes, again, I repeat, the common errors of student in using chain rule, they forget to multiply the derivative of the inner function. I mean, the inner function is this one, s minus 3. They forget sometimes this one. Let's say if we forget this one, they have the same answer, but it's not always the case. So always do not forget to include the derivative of your inner function. So let's have example. Let's have another example. This one, 3x plus 5 raised to 2. So our chain rule says the power becomes coefficient, and then we will less 1. So 2 times 3x plus 5 raised to 1. And then do not forget the derivative of your inner function. What's the inner function? 3x plus 5. So what's the derivative of 3x plus 5? 3. So 2 times 3x plus 5 raised to 2 minus 1, and then your derivative of the inner function. So 2 times 3x plus 5 raised to 1 times 3x raised to 0. Or simply 2 times 3 raised to 3x plus 5 times 3. And our final answer now here is 6x plus 10 times 3, or 18x plus 30. But sometimes it's okay if your answer is 6 times 3x plus 5. Sometimes it's acceptable, but if your professor or teacher ordered you or instructed you to get the final answer, it will be 18x plus 30. Is that clear? Okay, thank you very much. And let's have our final example. This one, 2 over 4 minus 3x. So we're going to do that. Again, do not forget to what? Can I hear from you? If our example is like this, how are we going to make that easier? We will what? Start with letter S. Maybe they are shy, Kaka.
I think so.
So we will simplify. Okay, so how we're going to do that? 4 minus 3x becomes 4 minus 3x raised to negative 1. Yan. And then we will now proceed on using the chain rule. So what's the process of chain rule? The exponent becomes coefficient, and then we will less 1. And do not forget to get the derivative of the inner function. So 2 times negative 1 times 4 minus 3x, negative 1 times negative 1 minus 1, and then your derivative inside, which is what's the derivative of 4 minus 3x? This one, 0 minus 3x raised to 1 minus 1. So it becomes negative 2 times 4 minus 3x raised to negative 2 times negative 3x raised to 0. Or negative 2 times 4 minus 3x raised to negative 2 times negative 3. And 6 times 4 minus 3x raised to negative 2. Or we can make 4 minus 3x raised to negative 2 as what? 6 over 4 minus 3x raised to 2. So that's our final answer. So is that clear? Theorem 1 to 7. So I hope you learned a lot in our discussion today. But of course, I will not end this session without giving you an exercise. So, Kaka, I have till 11:30, right?
Because we start earlier, so I think we have maximum 30 minutes more, maybe.
Okay. Okay. So I want you to try this one. So for us to check if you really understood our topic, so maybe you try this one. Try to answer. F of x equals the square root of x squared minus 4x plus 6. So maybe I'll give you 5 minutes to deal with this, and then later on I will give the answer only. The answer only. Or the process. F of x equals square root of x squared minus 4x plus 6. Now it's an application of the content and the tips that I have given earlier.
Come on,
Kaka, what is the age range of your first year college? They are college, right?
I think start from 18 maybe, or is there any 17 years old here?
Oh.
I'm not sure, but yeah, usually maybe the youngest one is 17 maybe.
Our age is not quite far.
Oh yeah, okay.
But
you already have your master in 23rd.
Because Kaka, in Philippines, we are the last batch before they implemented the K to 12. That's
okay.
why the batch before us or after us, I mean, they have an additional 2 years.
Oh, okay.
That's why. Because only few countries in the world, I think, only who didn't have K to 12.
Yeah. I think the average age of our first year students is about 18 actually, yeah. Because they usually complete their senior high school in 18.
Yes. 18 years old when our time is we're already in third year.
Wow.
College.
It's so young.
That's why they're all shocked every time they knew that I had my master's already at the age of 21. Because we are the last batch. Anyway, anyone in the group who have the answer already? So the first thing you do here is simplify. That's always the first thing. How? Since this is square root, this is a power of 1/2. So it'll become x squared minus 4x plus 6 raised to 1/2. And then you can now use the chain rule. 1/2 become coefficient, and then u less 1 to the 1/2. So it becomes x squared minus 4x plus 6 raised to negative 1/2. And then derivative of x squared minus 4x plus 6. It is 2x minus 4. And then based on that, you will now simplify. So that's the process. You just check your work later. So that's all for today. So thank you very much. And Terima kasih.
Okay, thank you very much for bench. Yeah, in case any students want to ask something to our lecture today, I will give maybe one question for you. Any? Are you already understand all of you about the topic today? Because it's, yeah, I see it's very clear, the explanation from our lecturer. Any question? Ada yang mau nanya? Enggak? Enggak ada yang tanya, udah capek. Okay, so I guess no questions for today.
There are no more questions.
Maybe Bench, you can give a close statement or maybe suggestion for our students so they can, can be more, spirit to study about mathematics.
They are mathematics major, Kakak.
All of them, actually no, maybe most of them from mathematics, but actually there are many other department, I think, but in the same faculty of Science and Technology. Ada yang selain matematika kan ya di sini? Yeah, okay. Yeah, from other department also.
Okay, guys. Always remember that we're always beginner. So do not be frustrated that you don't understand the lesson or the concept right away, because it takes time. You need to practice, because practice makes perfect in mathematics, and that's always the tips. If you're going to ask that to the mathematician or to your teachers, math professors, they always give you that advice that for you to be able to have a successful journey in mathematics, you need to practice, because practice makes perfect. And guys, always remember also that do not compare yourself to others, because sometimes if we kept on comparing ourselves to others, we frustrate because you saw your classmate, oh, she understood or he understood the concept already. I'm not, but me is not, something like that. Do not look that way. Instead, use that chance to see the positive side, that if he or she can do it, you can also. And in mathematics, it is a must that you understood the foundational or the basic concepts, because this will help you in understanding the higher maths. Because if you are in the higher maths, you're always going to the basic ones, because your basic ones, your basic concepts, your basic foundation is your companion, is your help in unlocking, in solving correctly the problem. So that's the tip. And also, I am in Indonesia on the next coming days. So maybe if we have the time to see each other, I can personally give my advice. So looking forward, guys, to meeting you there all very, very soon in Universitas Erlangga.
Okay, thank you very much for Bench. And I'm sure our students get a lot of knowledge, knowledge and a lot of experiences, because maybe some of them, this is the first experience to be taught by foreign teachers. So I think it's a good experience also. So thank you very much again for our teacher, Benchko Fabros. Hope to see you soon. Don't forget to come to Universitas Airlangga. We will welcome you well, of course. Okay, that's all from me. Thank you very much also for the lecturers who comes today. And then we will meet again, students, in the next week. So have a good weekend. Have a good holidays. See you. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Say thank you to our teacher.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Hope to see you there.
Thank you, sir.
Bye-bye, guys. Terima kasih.
Thank you.
Sama.
Thank you, Shir. Sama-sama.
Selamat.
Iya, Syah. Makasih kembali.
I hope I can understand what they are saying. Only a little bit of Bahasa I understand.
But it's quite good, I think.
Kaka, can I request for the copy of the screenshot a while ago
Oh yes, of course.
so that I can post also?
Okay, I'll send it for you.
Thank you, Kaka.
Welcome.
Can I leave now the Zoom?
Yes, sir. Thank you very much. See you.
Thank you so much. And to the chair of mathematics also, thank you so much.
Oh yeah,
Thank you
okay.
so much. And bye-bye. See you
Bye, see
very, very
you.
soon.